Math 102, example 2.6.6. So we've seen two ways to solve quadratics. We've seen factoring, and we've seen the square root property. Unfortunately, they both have limitations. Some things can't factor, or some things are just difficult to factor. And again, the square root property I can only use if I have something squared equals a number. So my final technique, the quadratic formula, will solve any quadratic so long as I first write it in the form of ax squared plus bx plus c equals 0. You can use this for every problem if you like. Now, I prefer to use the other methods when I can because they're a little bit faster, but again, this one will always work. So my equation here is negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I have x squared plus 3x equals 11, again, I have to have a 0. So if I don't have that, I need to first rewrite to get that. So here, a is 1, b is 3, c is negative 11. So let's put it in our formula and see what we get out. So I get negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, let's simplify that. 3 squared is 9, and 4 times 11 is positive 44. Watch those signs a little bit. I've got a 2 on the bottom. So adding up underneath the radical, I get 53. Now 53 is not a perfect square, but we do want to check to see if we can simplify. Now, unfortunately, 53 cannot be simplified, so that is actually our final fully simplified answer. It does look a little bit hideous, but we will sometimes get answers that look like that.